All right, so I'd like to welcome everybody to July 2020 Denver AWS Users Group Meetup. My name is David McDaniel. I go by Mac a lot of times. I'm the Director of Cloud Professional Services at Clinics and their Anthos Practice Lead. Here's my contact information in case anybody wants to get a hold of me. The agenda for tonight, if you've been with us more than once, you've seen our standard play here for communication items, some resources, and then moving on to tonight's main topic. So we do have a Slack channel. If anybody ever wants to get in touch with people that are doing AWS and have questions, you can join the channel. Just shoot me an email. I'll shoot you an invite. We also have our own Twitter handle that I try to tweet on about meetings. Not usually that good about it, but you will see updates. You'll see a post of tonight's slides and video. We're also listed on the AWS user group site under Americas. And if you have any announcements, I'd be happy to put them up here. Just give me a day or so notice. So for tonight's updates, a smaller list, but what we've got is EMR managed scaling. So now you can have AWS automatically manage your scaling activities for the Elastic MapReduce cluster service. They announced snapshots from any block device. And when they say any, they mean even on-prem or other cloud block devices. You can use snapshots to make backups of. Very interesting service. The well-architected framework has been updated with tools, white papers, and documentation. So be sure to stay current on that. SageMaker Ground Truth is video annotation and labeling through streaming video, which is pretty powerful. We've got EC Launch V2, which allows you to simplify your Windows configuration and launch templating to include software installation. Linux Live kernel patching is now available, where you can patch your specific Linux OSs live without downtime. And RDS proxy is now generally available. A couple interesting tools is the IAM policy generator that helps you generate at least template IAM policies based off a simpler language. And then there's the IAM security assessment tool. And this will help you understand what the security posture of your IAM policies are. And good tools to keep up on and use in your environment. Security being a very important topic, especially these days with people working from home so much. The corporate enterprise has been forced to basically extend their network into everybody's home. And that is not necessarily a good thing for security. So something you really need to be aware of and make sure all of your networking, VPN, and policies are in place. That pretty much wraps up the intro this week, or this month rather, and I would like to introduce Aaron Lieberman and Jerry Dixon from Big Compass. They will be presenting accelerating your development using CI/CD, AWS, and serverless. I'm going to hand it over to you now, Aaron.
Okay, thank you, David. So stop your screen sharing.
Yep.
I'll share my screen. All right. So we are here to talk about CI/CD. This is truly one of my favorite subjects. We've done some awesome deep dives on CI/CD, and we'll talk about CI/CD and AWS and combining AWS with the serverless framework, and that's serverless with a capital S. And if you don't know serverless framework with a capital S, we'll talk about that and define it, and we can answer questions about that. So we'll talk about those two components, which I'm very excited about. And then we'll talk about CI/CD and beyond, which I'm also really excited about, because I'm finding that a lot of people are implementing CI/CD pipelines, great processes around their DevOps, but not taking those extra steps. And CI/CD is really a foundation to be able to unlock a whole lot of things. And we'll just talk about a couple of those things in this presentation. And those can probably be spun off as even separate meetups. But first, real quick about me and about Big Compass. So I'm Aaron Lieberman. I also have Jerry Dixon on the call. I'll let Jerry introduce himself, but super quick about Jerry. He's a DevOps expert here at Big Compass and AWS expert here at Big Compass. He's one of our rockstar senior consultants. I'm Aaron Lieberman. I'm the cloud practice manager and architect at Big Compass. And so I lead our AWS practice. And I have been around integrations for a while now. And I was just telling David before this, I started actually in Web Methods, which is a software AG product, and gained my integration expertise in Web Methods, and then moved over more to MuleSoft. And more lately, just been using AWS. So for the last 4 or so years, I've been using AWS and combining that with solutions like MuleSoft, Web Methods, and the Dell Boomies of the world, and even going multi-cloud with things like Azure. But the majority of my expertise these days is with AWS, and I'm a certified solution architect and developer with AWS. I'm passionate about serverless integrations and DevOps and integrations in general. Big Compass, very quick, is a boutique IT consulting company based here in Denver, Colorado. And we specialize in integrations. So you're going to hear integrations a lot tonight, and related technologies. So we partner with companies like AWS because they power our integrations, right? And we truly believe that we can bring innovation to integration using these great technology platforms. And ultimately at Big Compass, we focus on building connections. And that's building connections between systems and apps and corporations, but most importantly, people. I think even in this time of social isolation, that building connections between people is even more important. And that's something that we've always focused on, from our culture to our clients to our community. And that's one of the reasons why we're presenting today. I'd love to meet more of you and just get more involved in the local community here. So let's get into it. The first thing that we'll talk about is deployment automation in AWS. So this will be CI/CD setup in AWS. And first thing that we want to talk about is why are we even talking about this, right? What are the pain points? What are you trying to solve when you implement a CI/CD pipeline? And one of the major pain points that I'm sure a lot of us on this call have been through is long-running deployments taking a large amount of effort. And this is such a huge pain point. I've even helped organizations and seen organizations plan for a deployment for an entire week, and then maybe that deployment even takes a couple of days. And really what you want to try to do is shorten that timeline, right? So you can spend time on innovation rather than on your deployments. So your deployments might be incredibly complex. You want to simplify that down with an automated process. And then you get errors deploying too. So maybe something gets stuck, or you can't SSH into a server, or what have you. You get errors deploying, and that just exacerbates problems and makes your long-running deployments even longer. And it's difficult to replicate to many instances. So for the majority of the time tonight, we're going to talk about just serverless today. But let's say you have a bunch of EC2s sitting behind a load balancer. If you need to deploy to 5 EC2s sitting behind a load balancer, well, effectively your work is times 5, right? If you're SSHing into each one of those EC2 servers and executing a script on each one of those, you have to do your checks and your commands on each one of those servers. So it becomes very difficult as you scale out to more instances when we're not talking about serverless. And then you get downtime on deployments. I'm sure, again, a lot of us have experienced this. I have experienced this. No business wants downtime on deployments because it's a lack of business continuity. So how can we accomplish CI/CD in AWS? And I want to preface what we're going to talk about here today with there's a bunch of ways to do this. And again, we're only really going to talk about serverless technology here today. And we're going to talk about just a couple of the ways that you can do this So let's get into one of the ways that you can implement a great CI/CD pipeline in AWS. And so dissecting this diagram, there's a lot going on here, but starting on the left-hand side in GitHub or whatever source control you might use. So if your developers are already going through a great service development lifecycle and checking their code into source control, that's a great start, right? Your CI/CD pipeline is going to integrate with your source control, whether it's GitHub, Bitbucket. If you want to go all day to AWS, it could be AWS code commit. And in AWS code pipeline, then that's going to be our first component of our CI/CD pipeline here today. And AWS code pipeline is an orchestration tool. An AWS code pipeline can watch your source control repository and check for commits to certain branches on that source control repository. So if you're going through your great service development lifecycle, right, maybe you make commits to develop after code reviews actually occur, your code pipeline would recognize those commits and develop and potentially deploy to your develop environment, your dev environment, right? And then you might have QA branches and release branches, and that would go to higher environments. And ultimately, your master branch in your source control would be deployed to your production environment. And then the second component here, moving in, is AWS code build. And AWS code build is responsible for actually building your code, and it can even go beyond that. And we're actually going to see that with serverless in the second part of the presentation today. But for the purposes of this, it's building code and creating an artifact that can actually be deployed to your serverless services. And then many times you would have a manual approval step in between your building step and your actual deployment step. And I've been really successful with this with my clients, and I've seen a lot of organizations implement this, where you want continuous integration, continuous deployment in lower environments. But when it comes to production, you might not want continuous deployment. You might want to cut that piece off and say, I actually want a manual approval step, or I actually want to deploy only once a week every Wednesday morning. And now you can implement this step in between your build and your deploy step to be able to control and throttle your deployment. So it's not a continuous deployment process in production. This is an optional step, but I would highly recommend it. And it's also to be noted here that this step is in between your build and your deploy step. And it's in between those intentionally because build sometimes can take a while. It can take minutes. Hopefully it doesn't get into the hours, but it can take a few minutes depending on the size of the code that you're building. And your approval, you want to come after that. And the reason for that being your deployment step is usually pretty quick after your code is all built. So you're basically preparing your deployment, and then you would have this checkpoint of the manual approval after your build is done, which is the lengthy part of the process. And then you can deploy after a manual approval fairly quickly. And that's the final step, which is in AWS code deploy. It would be the third step here, would be where you actually deploy your code. And AWS code pipeline is orchestrating all of this. AWS code deploy would be responsible for actually deploying your code. And within there, you see in this diagram, we elected to use CloudFormation. And we'll talk about that a little bit more later and why we made that decision. But we're using CloudFormation in this case to deploy to a couple of Lambdas and to be able to deploy assets to our AWS environment. And you could rip out CloudFormation with a couple different tools here, but again, we elected to use CloudFormation. Also, as I'm going through this, feel free to put questions in the chat, and I'll make a couple stops along the way, and we'll be able to answer questions. What does that look like with branching? So I just talked about branching, but visually, again, this is the same diagram, basically just replicated 2 times now. And the point of this diagram, again, starting on the left in GitHub, would be now GitHub has branches. So assuming you have multiple branches in GitHub, and one of those branches would be responsible for deploying to a lower environment like QA, and one of those branches would be responsible for deploying ultimately to production, right, your final stage. And this would probably be even replicated, 1 or 2 more times. A lot of corporations have dev, QA, stage, and production. You would replicate it that many times, and you would have your different code pipelines responsible for each one of those environments. Okay, so that's the nitty-gritty of CI/CD in AWS specifically, if you wanted to go with just AWS. But let's switch gears here a little bit and talk about the serverless framework. So the serverless framework with a capital S is something that we're really excited about here at Big Compass. It's something that's relatively new. I think there's a lot of hype around it, and we're not always going to recommend serverless, but we at least want to explore it and see how that can combine with AWS. So what is serverless? And if everyone doesn't mind, I believe there's in the chat feature, you can just say yes or no with the thumbs up, thumbs down. I'd love to hear, as I'm talking through this, who has heard of serverless and used it with the thumbs up, and who has not heard of serverless and not used it with the thumbs down, and we can look at that chat. So serverless framework, what is it? It's an open source framework allowing you to build and deploy applications. And so really, what does that mean? It's configuration based, that you create your configuration in YAML, very similar to CloudFormation, actually, if you've worked with CloudFormation. Once you install serverless, it comes with a great command line interface, and you can execute very simple commands like serverless build and serverless deploy to execute those build and deployment steps. And it'll automate a lot of things for you, is one of the great benefits of it, which we'll talk about here in a second. And it's fairly cloud agnostic. You can actually deploy it to AWS, Azure, and GCP, and a few other platforms as well. And when deploying to AWS, it actually uses CloudFormation under the hood. So if you know CloudFormation, serverless is not actually a huge leap for you to get there. But it's always important to take a step back, right? Again, we're not going to raise the flag of serverless and just tell you it's great in every single use case. Serverless is great in certain cases. So it's great for deploying serverless applications, and emphasis on serverless. So now if you have serverless services like DynamoDB, Lambda, SQS, SNS, serverless is API gateway. Serverless is going to be great for you. But once you start getting into the world of EC2s and RDS and things like that, serverless might not be the greatest use case. Serverless can speed up your deployment by quite a bit by automatically provisioning and mapping. And what I mean by that is, let's say you deploy a Lambda that's invoked by SQS messages. Serverless is smart enough to automatically map the invocation from SQS to Lambda for you. And so it eliminates some of the work that you would have to do, say, if you were using CloudFormation. It abstracts some of that work away, because serverless is smart enough to say, I recognize that I want to actually invoke these Lambdas based on messages that come into my SQS queue. And it can enable a multi-cloud strategy. I just talked about it's fairly cloud agnostic. The different clouds do have different syntax. So it's not cloud agnostic to the point of Terraform, for example, but it is fairly cloud agnostic and can enable a multi-cloud strategy at the click of a button. And it's also great for local testing and mocks of your cloud setup. This has been really useful for me and my team. And when you deploy to a cloud environment many times, let's just say AWS Lambda, you can locally test and do everything, run through your unit tests there, even do some integration tests locally, and then deploy up to the cloud in AWS, and you find that your Lambda doesn't work, right? I hate when that happens. But serverless now can actually start to mock that environment almost exactly, and it can mock that locally for you. And so you can actually now start to execute tests locally that mock your cloud setup. So really valuable in that respect. So serverless framework with AWS, it's great for build and deployment. And we're going to see here in a second, and in our demo, that serverless, through its YAML configuration, can do that build and deployment basically in one step. And that eliminates a step actually from your code pipeline. So it can take over that build and deploy your code just through AWS code build. And we'll take a look at how that works. And eliminating that step from your code pipeline is great. Your code pipeline becomes a little bit more simple, but of course there's a trade-off there that now your serverless setup is just a little bit more complicated. But of course you just have to take that into consideration, where you might have been doing CloudFormation instead, or you might have been doing Terraform instead. So it's a similar setup to those type of tools. So how do we implement serverless? So serverless, this is going to look very, very similar now. And again, starting at the left, we have our source control. And source control, a commit to source control will always be the way that we invoke our CI/CD pipeline. And I included the manual approval step here. Again, just an optional step, same type of thing that I just talked about. And now within our code pipeline, we see that the code build step now actually has two steps within it. So your code build step now is essentially executing two commands. It's the build and the deploy is how we're doing this. So you don't see a code deploy step anymore, because serverless under the hood within that build step is building everything that it needs to deploy your API gateway and your Lambda and your SNS topics and so forth. And it's being enabled to deploy all of your code to your AWS Lambdas as well and provision those resources. So very similar, but just slightly different here. And so taking a step back just a little bit, what do you have to consider when setting up your CI/CD pipeline? And Jerry and I considered, for the purposes of this talk, technology quite a bit, actually. And again, I wouldn't raise the flag of serverless. I wouldn't raise the flag of code deploy. I wouldn't raise the flag of elastic beanstalk in every single case, right? It just depends on the use case. And so code deploy is great in certain use cases. And code deploy might be great for deploying applications to EC2s or even Lambdas. SAM is very, very good also with the serverless services in AWS, but it's not cloud agnostic. CloudFormation, again, great with essentially all services in AWS. And the serverless framework, great with just those serverless services again, and can blast your deployments out to multiple clouds. Elastic Beanstalk, great with EC2s, and would highly recommend it if you're using EC2s. And then Terraform, again, great for the cloud agnostic approach. And then you want to consider different environments too. So we talked about different environments. You want to consider hooking in your service development lifecycle with your CI/CD pipeline. So I really can't stress this enough, because I've been on the receiving and the creating end of the CI/CD pipeline. And when your DevOps engineers come in and they implement a CI/CD pipeline that doesn't conform to what the developers are actually doing, and their branching model, and maybe they're following Git flow, and it doesn't conform to that, it causes a lot of unrest on the development team. And so as I think DevOps engineers, you want to think about those environments and coordinate with developers as well, and just make it a good user experience for them, because really it should be seamless for developers when you actually set this up. Security is a huge consideration here. And we'll look at just a little bit of security in our demo today, and we're happy to dive into this more. Could even be its own talk. But security, you can do things like protecting sensitive data and pulling things in at build time that's sensitive. You can encrypt data and decrypt and things like that. And caching. Caching is huge, and caching leads to your pipeline automation a little bit. So you can cache artifacts and resources. Let's say you have a JavaScript application and it's using Node. You're deploying Lambdas using Node. And you have a bunch of NPM modules, and it's 40 megabytes of data. And you want to just be able to cache those and reuse those, and only update when one of those NPM modules actually changes. You can actually do that and start to optimize your pipeline, so that the first time things happen, it might be a little bit slow, but then the second and third and so forth time is much faster, because you're only doing a diff of what actually changed. And then testing automation, and we're going to talk a bit more about testing automation here in a minute. But you always want to consider automating your unit tests at a very minimum within your CI/CD pipeline. And so what are we learning from all this? AWS and serverless is awesome, but only for serverless applications. So it only works in certain scenarios. And a more diverse or hybrid system, you might consider those other technologies, or even splitting up between your always on, like EC2, and your serverless services. And it's really important to note that CI/CD is evolutionary. I don't want anyone to think that you have to do it one way, or you have to be able to tackle everything at once. You can set up a CI/CD pipeline and then evolve it and iterate on it. And that's why the cycle is here on the right-hand side of the slide, where it's a cycle. Just like any other project, it's a cycle. You can plan and design and implement and test and deploy, and do that over and over and over to improve on your solution. And so now, above and beyond, I'm excited about these couple sections. We're going to move a little bit faster through these, but what we can talk about here is QA automation as one of the above and beyond topics that once you implement a great CI/CD pipeline, you can now start to think above and beyond and use that as a foundation to really start to enable your business to innovate and move quickly. So one of the things about QA automation, and one of the pain points, again, why are we talking about it, is that I've seen a lot of organizations have a lengthy QA or test cycle. And in that test cycle, you might even think, even no matter how rigorous you are, you still might have bugs deployed to production. We see it all the time, right? That's why we have to come up with rollback plans and rollback scenarios. And it might even be difficult to regression test. So say that you don't have great hooks into your system. It might be extremely difficult for you to actually regression test unless you have a great UI slapped on top of your system. It might be incredibly labor intensive to actually conduct QA, and that would slow down releases, slowing down your innovation, slowing down your iterations on your features. And I see this actually as one of the main pain points that I run across with my clients, which is lack of understanding of use cases. And that's not because anyone is not knowledgeable on something or not understanding. It's typically because of a lack of documentation. And you see turnover in organizations. You see people, wanting to move quickly and not necessarily taking care of the documentation like they should. And then a new QA test engineer comes in and tries to understand all of the use cases, but maybe a couple are missing, and it would be completely unaware to them. They wouldn't even know about them. And then that would get deployed to production, and then ultimately you would find a bug in production, right? So it's difficult to test all of those scenarios unless you have really great documentation. So there's a bunch of QA automation scenarios. I'm pretty sure most people here are probably familiar with these. I want to focus in on unit testing again here today, but your QA automation and integrating with your CI/CD pipeline could actually get into all of these scenarios. And again, that would be in probably a later phase in your CI/CD pipeline implementation. I wouldn't necessarily think about all of these right away, but I would think about unit testing right away. And you want to be able to execute your test-driven development, and you want to be able to do that automatically in your CI/CD pipeline. But you could also implement hooks along the way as you develop a system to be able to regression test and to be able to load test and stress test and so on and so forth. And it all starts, again, with why are we talking about this? Because we came from CI/CD, and now we're here at evolving our CI/CD pipeline. So well-defined DevOps is absolutely crucial here. And then it really works like any other project. You gather requirements and you capture those test cases, which are a part of your requirements. And a lot of times that's actually going to be the hard part in dealing with some of the organizations that we deal with today, especially with the lack of documentation, just uncovering all of those QA test cases. And then you can design an automated testing suite. And we'll look at how that might look here in a second. Of course, it's going to be different for every solution. But then you can implement functions to run through all of the tests and automate that so that you can hopefully now start to cover all of regression tests or all of your stress testing and be confident in that. And once that passes, you can feel confident in actually deploying that code. And then, of course, you would create a testing report. So you need visibility into that system. You would create a testing report, and that might look a little bit like this. And this is greatly oversimplified, so don't take this, don't take notes on this page, right? It's greatly oversimplified where if we're assuming that a system has some EC2 sitting behind a load balancer, for example, and that system has some hooks that we could hook into, maybe it's APIs. And we could make requests to those APIs to fully regression test that system. What it might look like in front of that is a user then could make a request to an API gateway that we could stand up in AWS. And then we could have a Lambda sitting behind that. And the real black box and the magic would happen, of course, in this Lambda or Lambdas, plural. And in here, you would go through all of those test cases that you had documented at the start of this project, and then dump a report out. Once all of those processes would be completed, or maybe they errored out, and you would dump a report out to, say, S3, and then provide a link back to whoever made this request to be able to go and look at that report. So just one example here, and again, greatly oversimplified. But what you want to consider here is for unit testing, think about your test-driven development. And then for all sorts of other kinds of testing, it's going to become more complicated, of course. So if you have a JavaScript project, for example, you can use Jest and automatically test your unit tests using Jest in your CI/CD pipeline. And Jerry can show that here in just a minute. But UI testing, you probably want to use some sort of tool, like Cypress or Selenium. And for regression and load and stress testing, a lot of times, in my experience, what I've seen is you have to implement something custom here and hook into those hooks that we just talked about in your system, or even develop hooks into the system if they're not already there. And security testing, you can also probe for sensitive data. There's also professionals that do security testing, and create those common types of attacks, and just report on those common types of attacks to help shore up the system. And with automated testing, some of the final considerations you'd want to take is you want to design your automated testing system such that changing requirements can mean altering your automated testing suite, but you want to try to avoid that at all costs. So you want to design for that in consideration, and try to mitigate that risk through configuration, and things like that. So exposing your configurations and making your automated testing suite dynamic enough to be able to handle those changes. And again, I'm trying to hammer this home. Always run unit tests where possible, right? And do that in your CI/CD pipeline. So CI/CD integration should automatically test for every single deployment, essentially, and that can be to all of your environments. That can be to dev and QA and stage and production, depending on how strict you want to be. And finally, last above and beyond topic would be provisioning new AWS accounts. And again, the CI/CD pipeline would set up the foundation to be able to provision new AWS accounts. And David and others on the call, I think we could even do a completely separate meetup just on this topic, because you can go really, really deep here, and there's a lot of different scenarios that you can talk about. So if people are interested in this topic and provisioning new AWS accounts automatically, and having those roll up into kind of one master account, and having a bunch of child accounts be linked to that master account, I'm happy to do that. So pain points. What are the pain points of not being able to provision child accounts off of a master account quickly and efficiently? And number one is account isolation. So I've seen many people combine their environments, for example, into one AWS account, and then you have dev, QA, and production traffic potentially colliding with each other. In terms of account isolation, you can also have different customers running on the same AWS account, and depending on compliance needs or even how you've set up your AWS environment, you never want customers' traffic to interfere with one another. And then you can also think about tenants. So if you have a multi-tenancy situation, say where you're trying to sell a SaaS solution to customers, you might want to think about spinning off different AWS tenants that would completely isolate that traffic and make it easier to actually sell a software as a service solution. And that would allow you to monetize that solution a little bit better too, because if you have all of your traffic running through one AWS account and you don't have a really good solution for separating all of that traffic, it might be very difficult to monetize. Because if all of that's running through the same solution from customer A and customer B and customer C and so on, you might not be able to detect how many requests are coming from customer A versus customer B versus customer C, and be able to, of course, charge them appropriately. And of course, time taken to manually deploy to new accounts. And so without automating this process, you might have a CloudFormation script to do this, but you are probably kicking off a manual deployment to spin up these child AWS accounts, and then spin up services within those child AWS accounts to be actually able to give life to those child accounts and link them to the master. So account creation flow, you have to think about two things. You really have to think about creating a new account, and that can happen with AWS organizations and CloudFormation. And then the actually more nuanced consideration is updating an existing account. So once you create those accounts, there's a lot of considerations to take into account, where if you want to update all of your existing accounts, let's say you have 50 of them, that's going to become unmanageable very quickly if you are manually deploying to all of your child accounts. And so you really need to start to think about the automation there, and think about if there's a feature release, does that get released to all of the child accounts linked to your master account, only to some customers? And so you can really start to get very nuanced there. I'm not going to dive too deep into that. And again, I'd love to talk more about that if anyone's curious. And so the considerations that you have to take, number one, no one size fits all. That's a theme throughout this entire presentation, that you have to use what's right for you and the technology that's right for you. Monetization should become a whole lot easier. You can implement a tagging process, or you can roll up your billing based on the child accounts that you're spinning off in AWS. And versioning is a huge consideration. So I just talked about that a little bit, but say customer A, B, and C are all child accounts of your master account, and you want to be able to deploy version 2 to customer A and B, but keep customer C on version 1 of your system. You really have to think about selective updates there versus updating all of your accounts. And of course, the more child accounts that you spin off, the more account management that you're going to have. So plan for that up front to be able to mitigate that risk. And account access, of course, is huge. So do you actually want to give access to anyone outside of who has access to your master account to these child accounts? And my favorite slide is the whole point of all this is CI/CD and QA automation and account creation is really DevOps nirvana, and there's probably other topics that we could talk about here also to improve your CI/CD and your DevOps. But combining all of these together, if you really think about that, if you have automated deployments and automated QA and automated account creation to be able to isolate traffic and spin off tenants and sell a SaaS solution, well, really, then you're in DevOps nirvana. You have almost everything you want, and your ability to iterate and go through your service development lifecycle quickly and efficiently has drastically increased from all of these. So this is really the ultimate goal. But again, iterate to get there, right? And you don't want to bite off more than you can chew at first. So would strongly recommend, just look at your CI/CD pipeline automation first, and then you can use that as your jumping off point. And finally, let's get into the fun stuff, which is the demo. And I'm going to stop sharing. Jerry Dixon from Big Compass is going to help me demo, and we're going to see CI/CD in action. So go ahead and take it away, Jerry.
All right, thanks, Aaron. Can everyone see my screen? Cool, I think it's sharing.
Yep.
Hi, guys. I'm Jerry Dixon, and I'm one of the senior consultants at Big Compass, and I specialize in AWS development and DevOps. And as you can see, I'm having a nice, relaxing day on the beach because I am in DevOps nirvana right now because I've set up just the best DevOps ever, and I have no more work to do. No, I'm just kidding. But I'm going to be showing you guys a couple of code pipeline projects that we've set up. One of them is it's a pure AWS project using CloudFormation to deploy a couple of Lambdas. And the second one is an AWS project that's using the serverless framework to deploy tons of different resources. So with that, I'll just jump into it. Before I begin, I'm going to go ahead and make a code change to our first demo, which is the pure AWS demo. And this is just going to kick off our code pipeline from the start. In this project, I have a couple of Lambdas, pretty basic hello world Lambda functions. And this is in JavaScript. I'm just going to make a change that will change this from defaulting to hello Mars to say hello world instead. I'm going to push this to the develop branch. And we should be able to see this actually kicking off our code pipeline here in just a second. All right, so it already kicked off the change in code pipeline, and I'm actually going to go ahead and make this change in master 2. I'm just going to make a quick pull request to master to kick off the change in our production code pipeline as well. Okay. And so these are our two code pipelines. We have one for production and one for our development environment. And now that I've merged into master, our production code pipeline's kicked off as well. I'm just gonna go step by step in the code pipeline and show what each stage and code pipeline looks like. So when you create a new code pipeline instance, AWS will walk you through a wizard that will take you through setting up a source step, a source stage, a build stage, and a deploy stage. Now, one thing to note is that you can have as many stages as you want. You can name them anything you want. This is just AWS's default because it's the most common use case for code pipeline. So real quick, we're going to go ahead and look at the source stage. And as you can see, it's linked to the GitHub that I just had open just a second ago. It's linked to pure AWS CI/CD demo. And this is linked to the develop branch. And it's keying off of GitHub's webhooks. It can also do some polling, which would be slower for releasing changes. It would take a little bit longer for the changes to go through code pipeline. Generally, it's recommended to use GitHub webhooks. Just to back up real quick, this is what an action in a stage will typically look like. You'll have kind of like a header for your action, and then you'll have a body for your action, and then finally at the end, you'll have a footer. Every action will have basically a name and a provider that you choose. In our case, this is our source stage, and we're choosing GitHub as the action provider. You can choose tons of different things as your action provider, and they all have different use cases, obviously. These are the 5 source actions that you can choose from in code pipeline. So this is code commit, which is AWS's own Git repository feature. Then you can choose Elastic Container Registry or S3 or Bitbucket, and obviously we're using GitHub for our source. Anyways, at the very end of a stage, you can specify an artifact, and this is key for passing on output of a stage to downstream stages. So in our case, code pipeline is taking the entire contents of our GitHub repository and it's zipping it up into a source artifact and passing it along as an artifact to our downstream actions. So we can move on and take a look at build stage. And again, you'll see some familiarity here. We've got our action name and provider. Obviously, we chose code build. And for code build, you have to specify a region. You have to specify an input artifact. And as you can see, we're using the source artifact from our source stage. So the code build has access to everything in our project's repository. And in fact, when you're setting up a code build step in code pipeline, you have to create a separate code build project or use an existing one. So most of the time, you'll create a new code build project when you're creating a code pipeline. So actually, you would usually click create project here, and AWS would take you through a little form for setting up a new code build project. Code build runs on an environment that's customizable to like different operating systems, different runtimes, and things like that. So you set up the environment yourself, and you can give it roles if you need to give it access to certain things. And then finally, you set up a build spec. You can either store your build specification in the code build project itself, or you can specify a build spec file. And this is usually the recommended approach because using a build spec file allows you to maintain the file in your Git repository instead of having it live in AWS itself. So I'm going to switch back over to the project code and actually show what this build spec file looks like, because this is key to code build, basically. So switching back over here, this is the build spec.yaml file that our code build is using. One thing to note is that code build has 4 different phases. It has an install phase, a pre-build phase, a build phase, and a post-build phase. The install phase would typically be used for something like installing a global dependency for your environment. So like say you need to have Maven as a global dependency that's just accessible from the command line. you would do that in your install phase typically. The pre-build phase can be used for something like this if you want. Right here, we're doing a yarn install, which is installing our node modules dependencies. And one thing to note here is you could move this down here. This is a lot of the reasoning for having it in different phases is somewhat for just separating things out. So you could like just have a build phase if you wanted to. We're just showing how you could use a pre-build to install your dependencies. And then in the build phase, we're running this long command, which is a CloudFormation command that lets you package your CloudFormation up to prepare it for deployment. So we can dive in real quick into what this is doing, because this is basically the meat of what our code build project is doing in Code Pipeline. So CloudFormation package takes in a template file. You can provide an S3 bucket, and then you provide an output template file. Now the way this works is we have this template.yaml file sitting here. This is a pretty small CloudFormation template. One difference from a normal CloudFormation template is that you would typically have an S3 URL sitting here pointing directly to your code sitting in AWS or something. But that is not as easy to use in a code pipeline, because then you always have to change your S3 URLs anytime you would change something about your Lambda code. So it's better to point your code to a local file path. In this case, we're pointing it to the entire project root as the file path. And what the CloudFormation package command is doing is it's going into our template.yaml. It's detecting any local file paths like this, and it is transforming them into S3 URLs. So it is zipping up our entire project's contents into a zip file and uploading it to S3. And in the end, we'll get this package.yaml file that will look very similar to this, except it has S3 URLs instead of local file paths. And actually, I'll show you real quick what that looks like. This is what our package.yaml will look like in the end at the end of our code build. And this is, in our case, what is being passed along to our deploy stage. So at the very end of, well, actually, I'll show at the very end of our build spec here, we have this artifact section, and you can specify as many files as you want to in this, but we're just specifying the package.yaml file that we get at the very end of this. So what we're gonna have is a zipped up artifact, much in the same way as our source artifact that was passed to code build. And this artifact is only going to contain a package.yaml. So in our code pipeline, moving along to our deploy step, show how that kind of links up. In this case, we're not actually using code deploy directly. We're using CloudFormation. And this is just another action provider. And obviously, it's a deploy provider. So this is meant to run a CloudFormation package template to provision whatever resources specified in your template. So you have to select an action mode. Typically, you would create or update your CloudFormation stack. And then you have to provide a stack name. And as you can see here, we specify that it's going to use the package.yaml file from our code build step in order to provision all the resources. And at the very end here, we have some IAM specific configurations. These aren't always necessary. It kind of varies from use case to use case. But in our case, we needed some certain permissions, and we needed to have these specified for CloudFormation. So that's what these are doing. And obviously, there's no output artifact for our deploy stage because there's no stages after this that need to happen. So I'm willing to bet that our code pipeline has completed. Yes, it has. And here's just a little bit of details of what a code build looks like as it's running. As code build's running, you get to see the logs of everything it's doing. So you can see those phases that I was talking about in the build spec.yaml file. There's your install phase. Obviously, we didn't specify one, so it's not doing anything. And there's our pre-build phase running yarn install. And so it's getting all of the dependencies. Our build phase, it's running that CloudFormation package command. And then finally, the post build, which is basically, it's doing a lot to get our artifact all packaged up, and then it's sending along to the next stages. So in the end, as you saw before, I changed the wording from Hello Mars to Hello World. So in the end, this is the resulting Lambda from our CloudFormation. And as you can see down here, it says Hello World in dev. In production, it should still say Hello Mars, actually. And the reason for that is our code pipeline for production has an additional stage for manual approval. As Aaron said, this is pretty commonplace to have in a code pipeline, because then you have a little bit more control over your production releases. And maybe you would have some other things in here, like Aaron was saying, perhaps an automatic deployment happening on a certain day at a certain time and stuff like that. So we're going to go ahead and approve this. And it shouldn't take too long for this code deploy to start.
I'll just reiterate there, Jerry. I mean, I think what you just said is awesome, because again, a lot of people actually want to cut off the continuous deployment part to production, and you want to have your continuous integration set up. You want to have your deployments ready in production so that it's push button deployments, but you actually want to cut off that continuous deployment part in production. So that manual approval step, again, as Jerry said, this is just one way to do it, but an extremely effective way to be able to control what goes to production at what time. And you can think about the people that would have access even to these pipelines to be able to come in and actually approve a production deployment.
Mm-hmm. Exactly. And just one note here too, in your deploy step, you're able to always click your details for most stages to see what it's doing as it's in action. So in our deploy step, when you click details here, it takes you to the corresponding CloudFormation project, which is really nice, because you're able to watch the events that CloudFormation is doing in real time. Obviously, ours is already completed, but if it's a really long CloudFormation project, you'd be able to hit the refresh button and see it provisioning things in real time, which is really nice. Anyways, our deployment has completed, so we go over here and we'll see that it says Hello World now. We're good to go. So that's an example of a pure AWS configuration using CloudFormation. We're also going to go ahead and show you a serverless framework project that sets up a multitude of different resources. And actually, this serverless framework project is a serverless framework accelerator project that we've been working on at Big Compass that is intended for helping you to get kind of a kickstart with setting up your own serverless project. So we're going to take a look at that in action within a code pipeline project. So just to start, again, I'm going to go ahead and, well, first I'll show you the lambdas that we're going to look at that get updated. These lambdas are very simple lambdas too, a little bit more complicated than our first ones, in that they're outputting some secret messages that are environment specific. So we're going to be able to see how environment variables can work in a serverless framework project as well. So I'm going to test this lambda. It's a pretty simple one. I'll run this one too. So all these lambdas are going to do is spitting out, it's returning the secret message. So this is a pretty bold statement. I'm sorry for anyone that's a Pepsi lover. So that's the secret message in dev, and the secret message in production is life is good. And it is if you utilize code pipeline as much as we do. So we're also outputting this Lambda version, which is just a dummy value that we have in our Lambda, and that's what we're going to update to kick off our CI/CD now. So I'll go ahead and open this project up. So I'm just going to go ahead and update the version of this Lambda to be 1.0.6 and get the code pipelines kicked off, just like I did for our last project. And I'm going to go ahead and merge these to develop and master. All right, so like before, we have a dev setup and we have a production setup for code pipeline. One big difference, though, is, as Aaron was saying before, we only need a build step, which is kind of an interesting factoid about the serverless framework. Is serverless framework does so much for you automatically that you're, in the end, able to run one command that'll do a bunch of stuff for you to package up your CloudFormation templates in the background and then deploy them. And it's all just one single command that we'll see in a second. It's serverless deploy. And if we take a look at this build, well, I guess it actually hasn't kicked off yet. Actually, so one thing to point out about code build is oftentimes you open up the build logs and they'll be blank like this. And that's because it's just queued. It hasn't actually kicked off quite yet. To be sometimes a little frustrating if you're an impatient developer like me. Okay, so I'm gonna switch over to our serverless framework project in the meantime while that's building, and I'm gonna show what the build spec looks like with this project. So again, we're running a yarn install. This time we're doing it in the build phase. We could do it in the pre-build phase. It doesn't really matter. We're running this interesting command called yarn decrypt. Then we're running yarn test and then yarn deploy. So we'll look at these three commands more closely now. Our yarn decrypt is in the background using, for those of you that aren't familiar with Node.js and how a typical setup looks, most configurations for a Node project live in a package.json file. And you can specify different scripts that can utilize your development dependencies under the hood. So in our case, we've set up some scripts that proxy to serverless. We've set up some scripts that do some other interesting things. First off, we're going to look at this script that proxies the serverless decrypt command. So serverless encrypt and decrypt is actually a command specific to a plugin in serverless. So serverless allows you to add plugins to your application. You can run your serverless code offline. You can integrate Webpack, as we're doing in our application actually. You can even use the serverless secrets plugin to have encrypted, you can have encrypted environment variables inside of your Git repository and then decrypt them, say, in your build step, like we are. So this is what they look like decrypted. This probably looks familiar. This is the environment variable that is being used, that's being output in in our development Lambda function. And this is what it looks like encrypted. This is what gets committed to Git. This is what I see locally, but it's not getting committed to Git. So this command here, yarn decrypt, simply taking in the stage as an environment variable that we've actually provided in our build phase inside code pipeline, and it's taking in a password too that we have in our build phase in code pipeline. I'll show real quick where those are. So like I said, there's our stage. We've set it to dev for our dev code pipeline, and then a super secret password for dev. Now, one thing to note here is you could put these in a secrets manager, actually. You could use a secrets manager to store secret things like this, but we like to live life on the edge and put all of our secret passwords in plain text. No, I'm just kidding, but for the demo, we're a little lazy and we just decided to go that route. Anyways, jumping back, so we decrypt this, and so now our code build has access to the contents of this file locally, and then we run our unit tests, which runs some simple jest tests in the background, and you can see that happening here. It just proxies to a simple jest test. And then we're running yarn deploy, which proxies to serverless deploy. And actually it runs this weird install layer command as well. Install layer, I don't want to dive too deep into what this command is doing, but essentially we're using, we're provisioning a Lambda layer in this application. And for those of you that don't know what an AWS Lambda layer is, it's a really nice way to well, say you have 5 Lambdas that all use the same node modules. A traditional way of having these 5 Lambdas would be to include the node modules in each one of their packages, and they would be kind of included locally within each Lambda. With a Lambda layer, you don't include your node modules directly in your Lambda packages. Instead, they all grab their dependencies from maybe a shared resource like a Lambda layer. And it's just a nice way of cutting down the size of your Lambdas themselves and letting them use dependencies from a shared resource. And it improves things like cold starts, because your Lambdas can, instead of being maybe 2 megabytes large because of all their dependencies, they might only be 20 kilobytes or something because you put all your dependencies in a Lambda layer. So we could talk more about Lambda layers after the demo, just to touch on what that is doing. And then finally, in the end, we're running serverless deploy. Serverless deploy is taking our serverless.yaml file that we were looking at here, and it is compiling it down to CloudFormation, and it is deploying the CloudFormation template and provisioning tons of different resources. So these are actually the functions that it's deploying. So a lot of different Lambda functions, and it's also provisioning a lot of different standard resources as well, like a Dynamo table, an S3 bucket, SQSQ, and some IAM roles that we need in order for our resources to work correctly. So jumping back, we see that, jumping back, we should be able to see that our code pipeline probably finished. And yes, it did. So like I said, it's just one build step, and you're able to go through and look at what all it's doing. So here we see all of the node modules getting downloaded. We see all these Lambdas getting packaged. And finally, in the end, we see serverless framework updating an existing CloudFormation stack. And it provides logs as it's doing that. And then in the end, hits our post-build phase, and everything is done at this point. Everything's deployed. So jumping back to our function here, sorry. Accidentally got out of the function. There we go. We see now that whereas before our version was 1.0.5. Now we should see that it's 1.0.6. And same here, 1.0.6. So there's actually a lot of other resources that our serverless framework has provisioned in here. Like I said, it provisioned a ton of different Lambda functions and dynamo tables. But I just wanted to give a high-level overview of how Code Pipeline can work in conjunction with the serverless framework. So that's all I really have to show. Can check and see if anyone's asked any questions.
Here, I can take back over the screen share.
Yeah.
And it looks like all the questions have been answered, I believe, for the most part. David, I'd be very curious to hear what your issues were with Java. And Shankar said, I've seen cold start issue with Java. Yep, definitely cold start issue is more prevalent with Java.
Oh yeah, add Hibernate in there, and you're really asking for trouble, which of course I did.
Yep.
So we ended up coming up with our own keep warm framework for doing basically each of our Lambdas was a domain service. So user was a Lambda, customer, address, order, things like that. And each Lambda had a URI for pinging it, which basically just made sure the database connection was still warm and responded and returned. So very quick service. And we would, we wrote basically a cron Lambda that pinged all the ping URIs every X amount of time. And then we had a way also of forcing a certain number of instances to be pinged. So, you know, if you ping too slowly and have too quick of a response time, you're going to keep pinging the same instance, which doesn't warm up another instance. So we actually had a fairly robust way of, during the day, ramping up the number of warm instances, and during the evening, ramping them down.
Yeah, unfortunately, with modern Java, with Graal VM and stuff, that's no longer an issue because you can get it down to native, even with Spring Boot and Micronaut, and even with Hibernate. You know, they've got the JPA support in there now for, you know, bringing things down to pure native code. So it's nice, tight, you know, even for cold starts.
Where were you 4 years ago, Jim?
Hey David, I'm curious how much money just AWS made just from your pings?
It actually fit in the free tier.
Oh, is it?
Nice.
Yep.
That's good.
It was. Sorry, go ahead.
I'd love to talk more about the serverless gotchas. Also, was going to be my point. You know, I think cold starts is a huge problem, and I don't know if you guys caught it, but Jerry talked a little bit there about Lambda layers too, and keeping your packages really, really small. And he actually used Webpack in that demo. And if you guys didn't catch that, and if you looked at the Lambda code, you saw that it was one line of code is what all of that boiled down to, and it was actually deployed to AWS. So that helps a lot too.
Nice. Yeah, layers didn't exist when I wrote the system, so there were, you know, they've made a lot of progress with the Firecracker VM, and the cold start time and layers would have been huge because we could have put Hibernate and all the libraries we depended on in a layer that we never touched, and which would have been shared across all the instances, which would have been really nice.
Yeah.
Yeah, and one thing I'd like to note about the serverless framework setup too is what's really nice about using layers in serverless framework is serverless framework orchestrates making sure all of your lambdas that are using a certain layer always are using the most up-to-date version, because if you're not careful about your DevOps, you could get caught in like this kind of vicious deployment cycle where you have to like update all these lambdas every time you need to add a new dependency to your layer, and it gets annoying.
Interesting.
So.
Yeah, I mean, serverless has
Hey,
come
Aaron,
a
just
long way since I mean, I think literally at the reInvent before they had really just come out and presented with AWS. So it was really very new at the time. So I'm sure it's evolved quite nicely.
Yeah. Well, I'll wrap up very, very quickly. We just have one slide here. Jerry and I are always willing to connect. As I said in the beginning, don't hesitate to reach out to us on social media or email. You can follow Big Compass. And again, we love this stuff. We're super passionate about it. I'm really excited about all this stuff. So if you want to dive deeper in any one of these, don't hesitate to reach out. And hopefully David will have us. We'll see you next time. We have plenty of content that we've been developing here at Big Compass. And I would love to take any more questions that you guys have.
Thank you for what you did for presenting.
No problem.
Thank you.
Great job, you guys. Really appreciate
thank
you guys
Thank
coming.
you, Aaron. Thank you, Jerry.
Absolutely.
Shankar,
Thank you,
Aaron,
Shankar.
Jerry.
Good to see
Awesome.
you, David.
Good to see you,
Virtually.
Shankar.
Yeah.
Yeah, it's been a while.
Yeah.
But thanks everybody for your time tonight. Really do appreciate it. And you guys have a great month. We'll see you in August.
See you, David. Be good.
Thank you, everyone.
Take care.
Have a good night.
Thanks.
Everyone.
See you
Thank
guys.
you.